This video will be about permutation and combination. Just like in our last lesson, permutation and combination deal with making choices. Specifically, they deal with the case where you have a group of n items and you're choosing r items from that set, and you want to know the number of ways you can do this. So the difference between permutation and combination is that in permutation, order matters. What this means is that inside this group of r items, you distinguish between the first person chosen, the second, etc. In other words, within the group of r items, you make distinctions between them. In combination, order does not matter. So this means that within the group of r items, all of the items are treated equally and have the exact same result. Examples of permutation are things like a locker combination, where it matters what order you put the numbers in, or choosing a group of people, each of whom has a different role. Examples of combination would be choosing a group of people who all have the same role. So let's say that we have a permutation involving n items and we're choosing r out of them. We can represent this with a big P, n on this side and r on this side, and the general formula for this is n factorial over n minus r factorial, where the factorial, if you recall, is equal to the number times the number minus 1, number minus 2, all the way down until 1. I can give you a little insight into why this makes sense. Recall from our example in the previous lesson where Alice had 7 books and she was trying to choose what order in which to read them. This is an example of a permutation because it matters what order she reads the books in. So remember that she had to choose which book to read as her first, second, third, etc., all the way down to the 7th. But what if, let's say that she only had time to read 4 books? In this case, we would have something represented by a permutation, 7 items, and she has to choose 4 out of them, and it matters what order she reads them in. Remember that for our first book, she had 7 different choices. For the second, she had 6, the third, 5th, and for the 4th, she had 4 choices. So we know that permutation 7 choose 4 is equal to 7 times 6 times 5 times 4. And basically what we're doing here is writing out the first r factors of n factorial, which turns out to be the same thing as n factorial over n minus r factorial. If we have a combination, we have a group of n and we're choosing r out of them, then the formula for this is n factorial over r factorial times n minus r factorial. Now I can give you a little insight into why this works as well. So remember our formula for permutation looked very similar to this. It's just n factorial over n minus r factorial. And so you see that this term is the same as this right here. So what we can say is that combination nr is equal to permutation nr over r factorial. Let's take our example of Alice reading books again. She has 7 books, and she wants to choose 4 to read. But now she doesn't care what order she reads them in. She only cares which 4 she reads at all. Let's just call these books A, B, C, D, E, F. So one example of the combination of books she can read is, let's just say, A, C, D, and F. Now, how does this combination relate to the permutation where the order in which she reads the books matters? Well, with this set of 4 books, she can read them in orders like A, C, D, F, A, C, F, D, A, D, C, F, etc. And the total number of ways that she can do this is the number of ways you can arrange 4 books in order. And the formula for calculating that is equal to 4 factorial. So this means that if you have a permutation, essentially what you're doing is first you're choosing the set of 4 books that you want to read, which is represented by combination NR, and then you're choosing the order in which to read them, which is represented by R factorial. In this case, R is 4, so that's why we have a 4 factorial here. So now if we wanted to solve for combination, then all you have to do is divide the permutation by R factorial, which is what we have here. When we have repetition in our group of items, we have a special type of permutation. And the formula for this is if you have n items, you're choosing R, and order does matter. And your first item is repeated A times. Your second item is repeated B times. Your third is repeated C times, etc. Now the way you calculate the permutation is you do permutation NR as usual, and then you divide by A factorial, B factorial, C factorial, etc. So for example, if I had a group of letters like A, B, C, D, and E, and I wanted to choose 4 of them to arrange, then the way I would do that is I would take permutation, the number of letters that there are, which is 9, I'm choosing 4, and then I would divide by, so our first item, A, is repeated 3 times, so we'll divide by a 3 factorial. Our second item, B, is only repeated once, so we're dividing by 1 factorial, so I'm not even going to write that in the denominator. C is repeated twice, so that's 2 factorial. D is also repeated twice, and E is only repeated once, so we don't have to divide by anything for that.